So today we're going to start talking about how angles are defined for trigonometry purposes as opposed to geometric purposes, which is how you used angles for all of your life. So starting with the definition of an angle, or at least our new definition of an angle, this time an angle is created by taking a ray and rotating it around a point. Whereas before it was just two rays that happened to share the same endpoint, this time we're physically rotating one of those rays to create our angle. So we can have both positive and negative angles depending on which direction you are rotating your angle. If you start with your ray and you rotate counterclockwise, that would be considered positive direction. If you take your ray and you rotate clockwise, that is considered a negative direction. So we have two sides of our angle. We have the initial side, or that first ray. The terminal side is where the angle ends, or where the rotation stops, or the second ray. Next definition is coterminal angles. These are two angles that have the same initial side as well as the same terminal side. So as you are rotating them around a point, they would land on top of each other. Now you can rotate more than 360 degrees. You'd form a full circle and rotate back, and that is when you would get the coterminal angles. Or you could rotate one in a positive direction and rotate the other one in a negative direction to end up with coterminal angles as well. For the most part, we're going to be looking at our angles on a coordinate plane. So you can see that our last couple of examples or vocab terms are talking about standard position as well as a refresher on quadrants. Hopefully you guys remember the quadrants. So we'll do that real quickly. The blue numbers, we've got Roman numeral 1 for the quadrant that's positive, positive. Roman numeral 2 is quadrant 2 for the negative, positive. Quadrant 3 is negative, negative. And quadrant 4 is positive, negative. An angle is in standard position on the coordinate plane when the initial side is along the positive x-axis. So that's our initial side, and then we would rotate either counterclockwise for a positive angle, or again, starting with our initial side, if we rotate clockwise, that would give us a negative angle measure. So I labeled each of the quadrants in between the quadrants with a degree measure as some reference angles that we can use as far as understanding which quadrant our angles would lie in. So obviously the initial side would be 0 degrees, or if you rotated the full rotation, 360 degrees. Of course, a quarter turn would be 90 degrees, half turn is 180 degrees, 3/4 turn through 3 quadrants would be 270 degrees, and then as I mentioned, the full turn would be 360 degrees. So we're going to start by drawing a few angles on a coordinate plane and getting used to that rotation, which direction it would go in and which quadrant it would land in. So our learning targets for today are sketching angles, as we just talked about, as well as identifying coterminal plus complementary and supplementary angles. I didn't put complementary and supplementary in the vocab because that is something that I truly expect you to remember from geometry, and we're going to cover that real quickly when we get to that example. All right, so sketching an angle in standard position. So our first angle that we're sketching is 75 degrees. So we're starting with the initial ray along the x-axis. And then because the angle measure is positive, we will rotate in a counterclockwise measure, remembering that that quarter turn would be 90 degrees. Up here, we're just going to give it an approximate sketch. We're not going to pull out a protractor and figure out exactly where it lies. But we know that it will lie in the first quadrant because it's less than 90 degrees. Of course, it's closer to 90 degrees than 0 degrees, so we're just going to make that terminal side of our angle closer to the full quarter turn. And that's our approximate 75-degree angle. Our next angle is 120 degrees. Again, we're drawing all of these in standard positions. We're starting with our initial ray along the x-axis, the positive x-axis, and then 120 degrees. Remember that quarter turn is 90 degrees, and a half turn would be 180 degrees. So the 120 degrees will lie somewhere in the second quadrant, and it's going to be approximately here, a little bit closer to the 90 degrees than the 180 degrees. So essentially, remember what we're doing is we're taking this initial side and we're turning it around the origin to get the terminal side for our angle. Our last two angles are negative. We're still starting with our initial side along the positive x-axis. And this time we're going to rotate our angle in the clockwise direction. So negative 170 degrees, if you think about a negative quarter turn, is negative 90 degrees. Negative half turn would be negative 180 degrees. So we're going to be fairly close to that negative 180 degrees with our negative 170 degree angle. And finally, a negative 400 degree angle. So thinking about our full rotation would bring us back to, and again going in the negative direction, our full rotation would bring us back to 360 degrees, or negative 360 since we rotated clockwise. 400 degrees is 40 degrees past that. So our terminal side would be about here. That would be our negative 400 degree angle. Even though we have 3 different topics, I'm just going to record these all in one video because each topic is fairly quick. So our next one is complementary and supplementary angles. Remember, complementary angles add to 90 degrees. So we take 90 degrees minus our 57 degree angle to get its complement of 33 degrees. Supplementary angles add to 180. So we take 180 degrees minus our 57 degree angle to get a 123 degree angle. That was topic 2, so we're going to move on to topic 3. Our last topic is coterminal angles. So what we're going to do is give the angle measure for an angle that would land in the same place as the given angle. And we have a coordinate plane set up so that we can sketch the angles. So starting with our initial, if we want to sketch a quick angle for the 60 degree angle, that would land in the first quadrant, approximately here. So we're finding 2 coterminal angles, one that is positive. So the way to find the positive coterminal angle will be to take this ray, rotate it the full 360 degrees plus 60 more. So you're going to take 360 plus 60 degrees to get our first coterminal angle of 420 degrees. So that is our positive coterminal angle. To get our negative coterminal angle, think about starting with the initial ray and this time rotating in the negative direction to get the 60 degrees. So you take 60 minus 360 degrees to get your negative coterminal angle of negative 300 degrees. Last example, starting with a quick sketch of our negative 30 degree angle, our initial side. Negative 30 degrees would be about here. So to get our positive coterminal angle, we would think about rotating it counterclockwise to get here. So we're going to take negative 30 plus 360 degrees to get our positive coterminal angle of 330 degrees. And to get our negative coterminal angle, we will think about continuing to rotate it in the negative direction. So we would need to rotate it 1 full rotation plus that additional 30 degrees. So we would take our negative 30 degrees minus 360 to get our negative coterminal angle of negative 390 degrees. And your U-Try questions.